So guys, hi everybody. Today, as you all know, we're gonna continue the discussion we had previous week. We're gonna continue our discussion on the various parts of an Eclipse data file. In the previous week, what did we cover? We covered the run spec section and grid section, right? Very well. Now, today we're gonna continue and cover props section and continue from there. Now, let us open up the data file that I sent you, in which the data file that we saw in exercise 1 is changed and units are getting converted from a field unit system to a metric unit system. And this is what you have to do for your assignment next week. So let us get on with it. Now, let me share the screen. The data file that I'm about to open up is the data file that I sent you previous week. I'm assuming that all of you have that. Now, the title of the data file was exercise 2 metric, right? Now, the last keyword that we got got acquainted with was the tops keyword. Now, and that was the end of the grid section. In the props section, we're gonna have different set of keywords. Now, what does the props section do? Anytime we have a question about a keyword on Eclipse, what do? We get referred to the Eclipse reference manual. How do we do that? Now, this is getting recorded, but you might not see it in the screen share of the Zoom. Now, we go to the simulation launcher, we click on the manuals, we press the run button, and the bookshelf is propped up in the PDF viewer that you have. Now, here I am in the bookshelf of Eclipse. Now I click on the reference manual, and in the I click on Control F and I search the keyword that I'm looking after. Now, wait a little. Props. Now, as the name implies, the props section is going to have something to do with the properties of rock and fluid in the reservoir that you want to simulate. Now, in the grid section also you input some properties of your reservoir, but in the props section the difference is that you are going to input the properties that are pressure dependent and saturation dependent. For example, you're going to input the rail perm tables, you're going to input the rock properties, for example, what? Go ahead.
Will you record it?
Yeah, I am recording it. It is getting
Victor,
recorded.
Mr. The last week, while you are recording until the minute of 13 and
Yes,
until half hour, there is no sound.
I
There
know,
was
I
no
know,
sound.
I know. There was a problem with the recording software. At the moment, we don't have that problem. Don't worry. It is getting recorded, and you're gonna have the. But after 30 minutes, the audio came back in the previous recording.
Yes.
Now we have the audio in the recording. Don't worry about that. Now, look. When we go to the props description in the reference manual, we see that the props section of the input data contains pressure and saturation dependent properties of the reservoir fluids and rocks. Okay? So it contains pressure and saturation dependent properties. Okay? Now, let us go back to the data file that we were working on. The first keyword that we see here is SWOF. Now, what are we inputting here? Here, we are inputting the relative permeabilities of oil and water with varying saturations for water, right? We are inputting the real data for oil and water with varying saturations of water. Again, when we don't know what is the meaning of a keyword, imagine that you are on your own and you want to find out about a specific keyword. You go to the reference manual, you search use the search option, and you're gonna find out about the keyword you are after. If you start when you're at the first page of the reference manual, it is better because you're gonna get the section of the reference manual that is dedicated to the specific keyword that you are after. Now, SWOF, in the description in the reference manual, it says water oil saturation functions versus water saturation, and you see here that it is dedicated to the props section. And here are invaluable pieces of information that tell you everything that you need to know. It says the first column is the water saturations. The second column is the corresponding water relative permeability. And the third column is the corresponding oil relative permeability when only oil and water are present. Okay? So, when you go back to the data file that you had, now you understand the meaning of these various columns that you have. Okay? The first column, as we know, is dedicated to various saturations for water. The second column is the relative permeability of water in these various saturations. And the third column is dedicated to relative permeabilities of oil with varying water saturations, right? So for example, when the saturation for water is 0.6, then the relative permeability of water is 0.330, and the relative permeability of oil is 0.004, right? Now, our objective in this exercise was to change the units from filled units to metric units. Now, here, is there anything that we need to change? Let's see. The saturation is a dimensionless property, So we don't need to change anything about it. It's going to have the same value in the metric system as it had in the filled system. The permeabilities in the metric system and in the filled system are both in millidarcies. So you're going to have no need to unit conversion on that front. And luckily, the pressures and the fourth column here, as you see here, is dedicated to capillary pressures of oil and water. Now, here all the capillary pressures that you have are 0. So you're lucky and you don't need to do anything here also. But if you had some capillary pressure here, you had to change the pressure, you had to do the unit conversion, and you had to change the PSI. You had to change these qualities from PSI units to bar units, right? And you had to divide it by 14.7, right? Now, what is the next keyword that you're seeing here? It is PVTW. And what does that mean? It means the PVT properties for water, right? That is the meaning of PVTW. If you need to find more information on it, you again have to go to the reference manual. But when you go to reference manual, you're going to see that the first column after the PVTW keyword is going to give you the reference pressure. Then you're going to see that the second column is going to give you the formation volume factor for water. Then the third column is going to give you the compressibility for the formation water. And the fourth column is going to give you the viscosity of water. Okay? This keyword is a very important keyword. Now, what are the changes that we need to make in order to do the unit conversion from the filled system to the metric system? The first column gives you the reference pressure in PSI. In order to convert it to the metric system, in which the unit for pressure is bars, you have to divide this value for pressure to 14.7. If you do that, you're going to get 276.8. Now, for formation volume factor, you don't need to do any specific unit conversion, because the formation volume factor is a dimensionless property, right? Now, so you see that in both systems the B of W is 1.029. For compressibility, you also need to do something. Why? Because in the filled system, the unit for compressibility is 1 over psi. So you have to change it to 1 over bar. How do you do that? You multiply this to 14.7 and the conversion is done. You can check the correctness of these calculations on your own. Now, for viscosity of water, what do you need to do? You see that in both the metric system and in the field system, the unit for viscosity is centipoise. So there is no need to do anything on that front. Okay, in both systems, the value for you have for the viscosity of water is going to be 0.31. Now, you see that all of these properties that what we are inputting into our data file are properties depending on pressure and saturation. The first set of properties, the rel perm of oil and water, was dependent on saturation. The second property that we are inputting, PVT data for water, is dependent on pressure. The next keyword is going to be the same. It's going to follow the same rule. The next this keyword is rock. What does it mean? Here you have to input the compressibility for the reservoir rock at a specific reference pressure. Okay? Now, in the data file that I gave you, the reference at the reference pressure of 14.7 psi, the rock compressibility of the reservoir was 3.0 times 10 to the power minus 6. Now, when you want to do the conversion to the metric system, you see that 14.7 psi is actually equal to 1 bar. Okay? And in order to do the conversion for the rock compressibility, you have to multiply this by 14.7, which is going to give you this. Right? So you have to do some changes for both fields of this specific keyword rock, R-O-C-K. Now, a very, very, very important thing to keep it.
Excuse me.
Go ahead.
And that's how you convert field unit to metric unit or CR.
Yes, for compressibilities in general, the compressibilities unit in the field system is what? Is 1 over psi, right? And the compressibilities unit in the metric system is 1 over bar, right? Do you hear me, Suran?
Yes, I hear you.
Now, in order to convert something that is in 1 over psi unit to a thing that is in 1 over bars unit, what do you need to do? You need to multiply it by 14.7. Why? Because every psi is equal to 1 over 14.7 bars. Do you understand me, Suran?
Thank you very much.
No problem. Very good. Now, the next keyword that you see here is density. What do you see here? In this keyword, you're going to see the densities for various phases of your reservoir fluid announced. Here, in the first column is going to be the oil density. The second column is going to be the water density. And the third column is going to be the gas density. These are all of these data that you see in the prop section and in the grid section are the data that are the result of laboratory experiments. So you're going to take samples from your reservoir, you're going to send it to laboratory, then the lab is going to give you the result of the experiments, and the compressibilities, densities, real-term data, PVT data, everything is determined, and you can use it to do your simulation. Now, imagine that the lab has announced these values for the densities of oil, water, and gas. Okay? Now, here we are using the field system. And what is the unit for density in the field system? It is pound over cubic feet, right? It is pound over cubic feet. That is the unit for density in the field system. Now, in order to have the density in the metric system, you have to do a conversion to kilogram over cubic meters. And how do you do that conversion? Here in the data file, I have written what you need to do. In order to convert the densities from pound over cubic feet to kilograms over cubic meters, you have to multiply them by 16.01846. Okay? You can easily see why that is true. Now, if you do that for every column here, you're going to get the density for oil to be equal to 786.5 kilogram per cubic meters. You're going to get 1037.8 kilogram per cubic meters for the density of water, and you're going to get 0.96976 for the density of gas in kilogram per cubic meters. Okay? Now guys, a very important to keep in mind here is that we need to terminate all of these keywords with a slash, right? You see that after every keyword, when we input our data, we use a slash in order to tell our compiler that this part of the code has finished. Okay? If you don't include this slash at the end of each keyword, what's going to happen when you do the simulation? The compiler is going to tell you that there are problems in your code and your simulation is not going to be done correctly. And that is especially a problem when you have very big simulations to do. Okay? Now, the next keyword that we see here is PVTDO. PVDO. What is that? Here, you enter the PVT properties for the dead oil, right? Yes, exactly, Soham. The system that you had was a dead oil system. Now, here you use the PVDO in order to input some properties of the dead oil that you have. Now, if you refer to the reference manual, you're going to easily see that the first column of this keyword is going to give you various pressures, okay, as you see, in the order of 3,000, 4,000, 5,000. The first column has given you various pressures, and the second column, just like a table, is going to give you the various formation volume factors for oil at those pressures that you see in the first column, right? So as you expect, the formation volume factor for oil drops by increasing the pressure, right? It has started with 1.26, 1.25, and it has decreased to 1.23, right? So the second column of this keyword is dedicated to formation volume factors for oil, and the third column of this keyword is dedicated to various viscosities for oil, right? Now you see that by increasing pressure, the viscosity for oil also increases, right? Just as what you expect. Now, what do we need to do here in order to convert the data that we have from field system to a metric system? The first column of data that we have here are pressures in PSI, and we have to convert that to pressures in bars. How do we do that? By dividing these values in the first column by 14.7, as we see in our result here. In the first column, every entry is equal to the corresponding entry in this, only divided by 14.7. Now, do we need to do anything for the second column? No, because the second column, exactly, the second column is a dimensionless value. So here you actually don't need to do any unit conversion because this property is unitless. Okay? What about the third column? The third column is viscosities in centipoise, right? And the unit for viscosity in the metric system and in the field system are the same. So for the third column also, you don't need to do anything. So the difference between this table and the original table that you had is only in the data that you have in the first column, right? Now, the last keyword that you see here is RS const, right? What does that mean? The RS const, we use RS here is what? RS here is the amount of gas, amount of solution gas that you have, okay? Now, here, when you use this keyword, you're going to see that the amount of solution gas that you have is given to you at the bubble point of the fluid that you have in your reservoir. That is how you input the data for your RS const. Now, The first entry of this keyword is the value of the solution gas, which is given as 0.4 MSCF over STB at the bubble point pressure equal to 3,300 blah 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 psi. Now, if you want to convert this unit for RS, which is MSCF over STB, to the metric system unit for RS, which is standard cubic meters over standard cubic meters, then you have to multiply the value you have for RS in the field system by 178.1076. If you ask me why, it is very easy. You have to do some calculations. When you do that and multiply 0.4 by 178, you're going to get some value around 71. And when you convert this value in the field system to the metric system and you divide it by 14.7, you're going to reach to this. Okay? Now, that is everything you need to know about the props section. Now, let us have this meeting only has 3 minutes left. Okay? I'm gonna end this meeting and I'm gonna send you another meeting link. Let us have a 5 minutes break and come back and have another meeting, and that will be it for tonight. Okay?
About PB, can you repeat that? The last one, PB.
Yes, that is the bubble point pressure.
I know.
Yeah? And the bubble point pressure in the field system is given to you, and it is equal to about 3,300 psi. Okay?
Okay.
And you have to convert that to bars, right? How do you do that? By dividing the pressure in the field system by 14.7.
Okay, I understand. Okay.
Very well, guys. See you in 5 to 10 minutes.
Okay, sir.
Guys, do you have my audio?
Yes, we can hear you.
Very good. Now, let us continue. Now, the next section of your data file here is the solution section. Now, the solution section, what does it do? In the grid section, you gave the simulator some properties like porosity and permeability, and you also determined the geometry of your reservoir. And in the prop section, you gave the simulator some reservoir rock and fluid properties, right? Now in the solution section, you have to make a link between these rock and fluid properties and the geometrical properties. And the keyword that does that for you is this equilibrium keyword. In the equilibrium keyword, you're gonna give the simulator a datum depth, and at that datum depth, the pressure and oil water contact and oil water capillary pressure and gas oil capillary pressure and lots of other relevant data are given, right? So this datum depth data serves as a reference point that relates the oil and water properties, the geometrical and rock and fluid properties to each other. The first column in this equilibrium keyword is the datum depth itself. The second column is the pressure at the datum depth. The third column is the depth of the oil-water contact. The fourth column is the capillary pressure between oil and water. The fourth column is the depth of the, I'm not sure about the fifth column. If you have to look it up in the yes, it is gas oil, the depth of the gas oil contact, right? Yes, it seems so. The fifth column is the depth of the gas oil contact. Now let's do the conversion from the field system to the metric system. How do we do that? This first column is a depth which is given in feet. You have to convert it to meters. How do you do that? You divide it by 3.4 blah blah blah. You're gonna reach to this as the datum pressure in meters. When you want to convert the second column from PSI to bars, you have to divide it by 14.7. When you want to convert the third column from feet to meters, you have to divide it by 3.4. And the capillary pressure is 0. If it was not 0, you had to divide it by 14.7. The gas oil contact is in feet. In order to convert it to meters, you have to divide it by 3.4. And all the other fields are 0. So you don't have to do anything about them. Now, equilibrium is the main keyword that you're going to use in the solution section. And that's going to be it for the course that for the simulations that we're going to do at our level. Now, after this, the next section is going to be the summary section. And this is a very important section of your data file when it comes to seeing the actual results of your simulation. In the summary section, you see keywords like FOPR, which don't have these keywords don't need a slash to terminate them. They have no input data. They are just a signal to the simulator to create a report which FOPR stands for, and that is field oil production rate, right? Now, FOPT stands for field oil production total. WCT, FWCT, let me minimize this so you can hear it, you can see it clearly. Now, FWCT stands for field water cut. FPR stands for field pressure, average field pressure. FOIP stands for field oil in place. FGPR stands for field gas production rate. WWCT stands for well water cut for all wells, right? And you see that these keywords which start with W give you the capability to point to the individual wells that you have included in your simulation. And if you name those individual wells, for example, I1, P1, I2, P2, then you need to terminate the keyword with a slash, right? And so on and so on. Look, these keywords that you have included in your summary section have a specific importance. When you do your simulation and everything is over and you want to go to the office to see the results of your simulation, you remember that when you loaded the result of the simulation in the office, then you saw two sets of keywords. Some keywords starting with F, which were field keywords. Some keywords starting with W, which were well keywords, and gave you the result of the reservoir simulation in various ways. Maybe you want to see the average reservoir pressure, then you use FPR. Maybe you want to see the water cut for the whole field, then you use FWCT. Maybe you want to see the water cut for individual wells, then you use WWCT, right? So this section of the data file, this summary section, controls what you're gonna see in the results of your simulation when you open up the office part of the Eclipse. Okay? The summary section of your data file controls what you're gonna see in the result of your simulation when you use Office. Okay? Now we are familiar with the Office, and you remember what you saw when you opened up Office. And maybe over there you ask yourself, why do I see these F keywords and these W keywords in the Office? Now here is the answer to that question. Those keywords come from this part, the summary part of your data file. Okay? Now, there are lots of other keywords that you can use in the summary, and when you go to the reference manual, there's a complete list of the keywords that you can use in the summary section of your data file, and you can get full acquaintance with these keywords over there. Now, questions? Guys, I'm hearing noises from you. So guys, that is it for today. Uh, the assignment that I gave you is postponed to the next week. I'm gonna open up a slot in the LMS system for you to upload your assignments over there. If you don't have any questions, that's gonna be it for tonight.